All right, in this video, we're going to do EOC review number 17. This is our last week of reviews. All right, so in this first part, which is a quick review, we are asked to simplify, and we're using exponent properties. So if you're struggling with this skill, I suggest looking back at section 1 and you're looking for exponent properties. You can also look on YouTube for exponent properties, or ask Ms. Shishagwe or Ms. Inuez for some extra practice on exponent properties if you need it. So we have x to the fourth times x to the third. That's going to equal x to the seventh because we're going to add those exponents together. When we have x to the third, and then that's going to be squared, then we are going to multiply those exponents together. So we're going to have x to the power of 6. Okay, in question 3, we have 2a squared times b, and that's all going to be cubed. So we have to distribute that cubed to each term in the parentheses. All right, so in this video, we're going to do EOC review number 17. And I'm going to make sure to zoom in real big so that I have plenty of room to write. Okay, so in this first few review problems, we are using our exponent properties. And make sure that if you do not remember your exponent properties, to either look up a video on YouTube, or go back to your Math Nation, or go back to your notebook if you happen to keep all of your notes from the years, because we did do exponent properties in our notes with section 1. Okay, so number 1 says we have x to the fourth multiplied by x to the third. So this is our this is our product of powers property, so we're going to add those two powers together, and so we get x to the seventh. In our next example, we have x to the third squared. That's a power to a power property, so we're going to multiply those two exponents together, and we get x to the sixth. In number 3, we have a power to a power, but we have 3 different terms in this parentheses, so we need to remember to distribute that 3 to each term in the parentheses. So that's like having 2 cubed multiplied by a squared cubed multiplied by b cubed. So to simplify that, well, 2 cubed is 2 times 2 times 2, which is 8. Then we have our power to a power here, so that's going to be a to the sixth, and then we just have our b to the third, and that's our final answer for number 3. Number 4, that's our quotient power rule, and so we're going to take that 10 and subtract 2, so we get y to the 8th power. Now number 5, again, we're dealing with just like we did in number 3, where we have to distribute that to both terms, or where we had to distribute that to 3 terms, we're now going to distribute that to both terms in the parentheses. So x cubed is going to be x cubed to the 2 power over y squared to the 2 power, which equals x to the power of 6 over y to the power of 4. Make sure that you're distributing that exponent to both terms inside the parentheses. Okay, and number 6, we have ABC to the 0 power. Well, anything to the 0 power is always going to be equal to 1. Because to the 0 power, what you're doing is you're doing ABC divided by ABC, which anything divided by itself is always going to equal 1. So that's our 0 product, 0 power property, sorry. Number 7, we have a negative exponent. And when we have a negative exponent, we flip it to a fraction. So this becomes 1 over x squared. When our exponent is negative and it's in the denominator, then we're going to do the opposite. We're going to flip it to the numerator. So we're going to have y cubed. And it's over 1, but we don't ever write it over 1. It's just going to be y cubed. And then we have 3 multiplied by the square root of 27. Well, this is a radical that we need to simplify. And to simplify a radical, we're going to take 27 and we're going to use our prime factorization tree, our prime factors tree. And that's going to be 3 times 9, which is 3 times 3. So this is equivalent to 3 times the square root of 3 times 3 times 3. And if I have 2 of something underneath the radical, I can pull out 1. I can pull out 2 and it's going to become 1. So that becomes 3 times 3, and I'm left with this 3 underneath the radical. So 3 times 3 is equal to 9, so I have 9 square root 3 as my final answer for number 9. Okay, number 10 says write x to the 3 halves in radical form. So we have a denominator and a numerator. And so when we have this and we're writing it in radical form, that's going to be the square root. So just imagine that 2 there over the square root of x cubed, because that cubed is the exponent with the variable, and your denominator is your root. So number 11 says write the third root of x to the 5th with rational exponents. So we're going to do the opposite. So we're going to take that 5 and that 3 and write it in exponent as a rational exponent form. So we're going to have x to the 5 over 3. That 5 that was underneath the radical is now going to be my numerator. And that 3 that was my root is my denominator. Your denominator is always your root. Your numerator is the exponent of variable. Number 12, fill out the table by putting checks in the boxes for which classification of number is obtained by the given operation. So the sum of 2 rational numbers. So we're going to have r plus r. Well, that's always going to equal a rational number. The sum of a rational and an irrational number. So r plus I, that's always going to give me an irrational number. The product of 2 rational numbers, So r multiplied by r will always give me a rational number. The product of a rational and an irrational number will always give me an irrational number. Now remember, when you have an irrational times an irrational, and we talked about this at the beginning of the year in our notes, if you have an irrational number times an irrational number, it can be both. So that's sometimes true. It can be true for either rational or irrational. So we have to be careful with this one. All right, number 13, simplify this exponential equation. So what we need to do is look at our exponents. And I believe this here is a multiplication. So first what we're going to do is simplify our numerator. So we have x squared multiplied by y to the fifth multiplied by x cubed multiplied by y squared. So we're going to get x to the fifth because we're going to combine our exponents by adding. And then we're going to combine our y exponents by adding. So we're going to get y to the seventh. And that's divided by x to the fourth over y cubed. And so now we're going to combine our exponent rules as a quotient. So x to the fifth minus x to the fourth, or 5 minus 4, is going to give me an x. And then we do it for our y's. 7 minus 3 is going to be y to the fourth. So just break it down step by step. Okay, number 14 says simplify the square root of 3 plus 2 square root of 3. Well, these radicals are the same, so that's like having, it's similar to treating that square root of 3 as a variable. So if you have 1 square root of 3 plus 2 square roots of 3, you're just going to end up with 3 square roots of 3. And that's it. Because there's an imaginary 1 there. 1 plus 2 is 3. Simplify 3 square root of 27 plus the square root of 12 minus 2 square root of 3. So what we're going to do first is we're going to simplify this 3 square root of 27. So 3 square root of 27. 27 can be factored into 3 and 9 and can be factored in 3 to 3. So this is equivalent to having 3 times the square root of 3 times 3 times 3. So I can take out these two 3's and I'm left with 1 3 underneath the radical. So it's going to be 9 square root 3. Okay, so 3 square root of 27 simplifies to 9 square root 3. So I'm going to write that number first. 9 square root 3. Then I need to simplify the square root of 12. The square root of 12 can be simplified into 2 and 6 and 2 and 3. So that's equivalent to the square root of 2 times 2 times 3. I have a pair of 2, so I can pull them out. So I'm going to have 2 square root 3. So the square root of 12 can simplify to 2 square root 3. So I now will have plus 2 square root 3. And this minus 2 square root 3 cannot be simplified any further. So now I just have to combine my like terms. Well, 9 plus 2 square, 9 square root of 3 plus 2 square root of 3 minus 2 square root of 3 is just going to equal 9 square root of 3. Number 16, simplify using only positive exponents. Okay, so what I need to do here is anytime I have a negative exponent, like I do here and here, I have to rewrite that with a positive exponent. Okay, so 2 to the negative 1 is equal to 1/2. X cubed is just x cubed. Y to the negative 5 is 1 over y to the 5th power. So now we have to make that just a little bit simpler. Okay, so this is really over 1, so we can write this as x cubed divided by 2y to the 5th. Okay, so let me write that just a little bit better. So we had 1/2, because 2 to the negative 1 is 1/2. That's multiplied by x cubed over 1, because you can always put any number over 1. And it already had a positive exponent, so we didn't need to change it. And then y to the negative 1/5 became 1 over y to the 5th. Multiply those straight across, and you get x cubed divided by 2y to the 5th. Number 17, write in radical form. So we have a to the 3/2 over b to the 5/2. So this 2 is my denominator. I want to use the same colors I did before, and I did. Good. Okay, so I'm going to have a radical with a 2 as my root. And underneath the radical, I'm going to have a cubed, because that's my numerator, multiplied by b to the 5th, because that's my other numerator. And now I wrote it in radical form. Number 18, write with rational exponents. So now we're going to take this 3, our root, and that's going to be in our denominator. So we're going to have x to the 7 over 2 multiplied by y to the 3, I'm mixing up numbers, 7 over 3, because 3 is the root, times y to the 2 over 3, because the 3 is the root. Number 19, which step should be placed in the blank to make this solution correct? So we're looking at A, B, C, and D. So what we're doing here is there's an implied 2 there, because that's the root if it's a square root. So there's always an implied 2 there, even if it's not listed. So that's going to be the same thing as x to the 8 over 2, which 8 over 2 simplifies to 4. So the correct answer here is C. Then we have number 20, which of the following are equivalent to the square root of x cubed? Again, there is an implied 2 there as my root, and the root is always my denominator. So that's going to be x to the 3 over 2, or x to the 3/2. And which ones match x to the 3/2? So we have there, and also that one, because 3 times 1/2 is going to be x to the 3/2. This would be x to the 3 plus 1/2. Oh, we could also write this as x to the square root of x. So this is equivalent. And this is also equivalent because this is 2, and this would be equal to the square root of x cubed. So whether that is outside of the parentheses or underneath the radical, it is the same. Sorry, I don't know why I marked that one. So your correct answers here are there. I did have that right. All right, that is your EOC review number 17. If you need to review your exponent properties, please contact me in Teams and we can practice it, or I can give you some review worksheets.